Indianapolis Motor Speedway is the biggest sporting arena in the world. It's home to the largest live spectator event on the planet and was designed for one reason: to showcase drivers racing high-performance cars at breathtaking speeds. But when the Speedway announced plans for the most ambitious redevelopment in its history, it would be battling not only against time and bad weather, but against the very limits of design and technology. It's the largest sporting arena on Earth, host to an estimated 400,000 fans, more than 5 times the capacity of Manchester United's Old Trafford Stadium. Spanning more than 4 square kilometres, this mecca of motorsports is as big as a small city. It's so big it could hold all of the 31 National Football League stadiums in the US and still have room to spare. The Indianapolis Motor Speedway is one of the world's true megastructures. It has its own fire department and medical center to deal with emergencies. There's parking for nearly 50,000 cars. There's a championship golf course with 4 holes inside the oval track. There's even a museum dedicated to the rich history of the sport. It's probably the most technologically advanced racetrack in the world. Drivers here career around the 4-kilometer oval at speeds close to 400 kilometers per hour, traveling the length of a football field in under a second. These featherlight cars have an incredible 675 horsepower, accelerating to more than 150 kilometers an hour in less than 3 seconds. But they get less than 1 kilometer per liter, not exactly suitable for downtown driving. The Indy Speedway is the oldest purpose-built racetrack in the United States. It opened its gates in 1909 as an automotive test facility when Indianapolis was still a major car manufacturer. The original paved track was built from more than 3 million bricks, giving it its nickname, the Brickyard. But over time, this has been replaced with probably the smoothest, safest, and most sophisticated asphalt paving in America. The Speedway has always strived to be at the forefront of motor racing. It was the first to install accelerometers into racing cars. Like an aeroplane's black box, these gather crash data, which helps in the design of ever safer cars. The Brickyard has also been at the vanguard of developing revolutionary crash barriers that are now installed at almost every racetrack in the United States. But it was in the late 1990s when the Speedway experienced the biggest transformation in its history. The Speedway's owner, Tony George, had some ambitious plans for the track. But he realized that he would have to break with over 90 years of tradition if he was to see his dreams come true. For nearly a century, the Speedway had been home and shrine to just one event, one of the most famous motor races on the planet: the Indy 500. Every May, around 400,000 people descend on Indianapolis for what's known as the greatest spectacle in racing. This iconic sporting event is synonymous with the famous track. 33 high-performance cars and their drivers start the 200-lap course. They can cover 800 kilometers in just over 3 hours. At that speed, they could cross the entire United States in a little over 12 hours. The Indy 500 had been the sole annual race at Indianapolis since 1916, but the Speedway's owner had decided to make a dramatic change. To keep up with economic demands, he wanted the track to be used throughout the summer. If his plan worked, it would mean that the stadium would pay host to not only the biggest live sporting event on the planet, the Indy 500, but it would also introduce NASCAR stock car racing and try to lure Formula One back to the United States for the first time in nearly a decade. It was a bold move and a massive undertaking. What's more, if it backfired, the Speedway could upset the very core of its success, the hundreds of thousands of dedicated Indy 500 fans. In 1994, Tony George put his ambitions to the test. On the 6th of August, the Speedway hosted the inaugural Brickyard 400, part of NASCAR's Winston Cup. It was a huge hit. More than 300,000 fans turned up, making this the second biggest sporting event on Earth after the Indy 500. But the race revealed a major flaw at the track. The single most important building at the Speedway is the control tower. This is the brain of the track, in charge of vital public and raceway safety, and from where critical race day functions are performed, like marshalling, timing, and scoring. But the tower was nearly 40 years old and showing its age. The concrete was deteriorating, the steel was rusting, and many of its facilities had become outdated. The small 6-story tower, built in 1957, stood less than 23 meters high and covered an area of only 58 square meters. But the Speedway's owner envisioned a super-modern, state-of-the-art tower almost 10 times this size. It would house high-tech broadcast and hospitality facilities and some of the most sophisticated racing equipment in the world. But there was a catch. While the tower was to reflect the future, he also wanted it to pay homage to the Speedway's legacy. The first control towers were built at the Speedway in 1913 and 1926, in the style of Japanese pagodas. No one today knows the story behind their design, but they had become synonymous with the track's history. It was the Speedway's wish to continue this tradition. In 1995, a design team set out to fulfill Tony George's dream of creating a structure like none other on the planet. The Speedway's chief architect, Jonathan Hess, wasn't at all familiar with this design.
I don't think that you see many pagodas being designed and built these days, certainly not in the Midwest.
And for chief engineer Kevin Forbes, it would remain a headache for nearly 2 years.
The challenge was to build the new pagoda in virtually the footprint of the old control tower.
To create enough space to build the huge new pagoda meant dismantling the old control tower and the vast half-kilometer, 30,000-seat grandstand that surrounded it. And that wasn't all. This mega build would have to continue on through 2 full seasons of the planet's biggest sporting events. In 1998, the Indianapolis Motor Speedway was about to undergo the biggest and most ambitious redevelopment in its history, and it would have to be completed in just 18 months. The design of the new pagoda control tower had already taken architect Jonathan Hess several years to perfect. He'd been under enormous pressure to get it just right, and had 400,000 dedicated Indy fans scrutinizing every detail.
The magnitude of this place is really quite special and unique. The history of this place is unparalleled.
Hess met the high-profile challenge with genuine originality and creative flair. The vast new pagoda would stand 60 meters high and cover 7,500 square meters, making it 16 times bigger than the old tower. A massive central concrete core weighing more than 11,000 tons would bear the load of the whole pagoda, while at alternate levels, the structure would be cantilevered with exposed steel to form exterior viewing decks. It was a complex design, and one that would push engineering and Kevin Forbes to the limit, especially as the Speedway owner wanted it finished for the 2000 race season, less than 18 months away. But that wasn't all. The Indianapolis Motor Speedway was like no other place on Earth, the largest stage in the world, where hundreds of thousands of fans came every year to see their heroes race. Closing its gates for 2 seasons to accommodate construction was not an option. The show would have to go on. But there wouldn't be enough time to build the tower in the 10 months between the end of the 1999 race season in August and the beginning of the 2000 season the following May. The only solution was to build in 2 phases, through the winter of 1998 and again in 1999. But if the original tower was demolished to make way for the new one, then how would race control function during construction? The builders considered moving the new tower and constructing it in a new location. But the Speedway's control tower had stood in the same place for nearly a century. This mythical footprint was almost sacred ground. And apart from that, there wasn't any other space available in which to build. Every centimetre of the enormous speedway was already accounted for. The only solution was to dismantle the upper 4 floors of the old tower, leaving the first 2 floors with the vital race controls intact. Then, they would start to build the new pagoda tower around and over the shell of the old one, essentially building from the top down. It was a novel idea, and one fraught with potential problems. On the 1st of September 1998, after 4 years of meticulous planning, construction finally began. They started with demolition of the 30,000-seat grandstand south of the control tower. Using hydraulic excavators with claw-like devices, they chewed up the half-kilometre-long structure. They removed 5,500 tons of reinforced concrete, over 370 truckloads. To meet the tight deadline, the construction team needed to have the massive central core built within a year. But during that time, the Speedway would cater for 2 of the world's largest sporting events. And to make a difficult job next to impossible, the owner wanted no visible evidence of construction. It was a logistical nightmare for Chief Engineer Kevin Forbes.
Basically, you have 2.5 months there that you can't really do anything, and for a project that had such a critical schedule as this one, 2.5 months is virtually all the time in the world.
Building the new tower on the same footprint as the old one presented some serious problems for the team. The first 2 floors of the old control tower would have to remain intact and functional. But the skeleton of the new tower required the removal of the top 4 floors of the old one. This risky operation required nerves of steel and surgical precision. Just one wrong move, and the first 2 floors could collapse. The demolition crew cut through the support columns 1 floor at a time. During this process, the 200-ton building would have only a crane for support. The enormous crane would then pick off each floor. It was a delicate and nerve-wracking operation, and one that couldn't be rushed.
We weren't really sure what was going to happen the very moment that the saw actually went through the 4 columns. You talk to the crane operator himself and say, how well do you feel about this particular lift? Well, again, This operator has never actually picked an entire floor of a building before, so he was just a little bit nervous.
Slowly, they began to lift off the first floor. It was an intricate operation that took 8 intense days to complete. So far, everything was going according to plan. But 3 months into construction, with crews already working against time and weather, the Speedway owner dropped yet another bomb, one that would send Kevin Forbes and his team rushing back to the drawing board. The Indy 500 is the biggest motor race in America, but Europe has Formula One. Outside America, this is even bigger than the Indy 500, broadcast to over 132 countries with approximately 1 billion viewers worldwide. It's a massively popular sport and a multi-billion-dollar business. It's also one of the most expensive sports, with each team paying out up to $120 million a year to compete. Such huge outlays mean that Formula One is an extremely demanding client. The US Grand Prix had been a highlight of the Formula One season for nearly 40 years, but due to rising costs and lack of support, the last one had been in Phoenix in 1991. It had been Tony George's long-time dream to bring Formula One back to the US. On the 1st of December 1998, he announced that Formula One had agreed to make Indianapolis the new home of the US Grand Prix. This would make the Speedway the only track on the planet to host 3 of the world's premier racing leagues: Indy Racing League, NASCAR, and now Formula One. But realizing this dream would cost around $50 million. The demands of hosting a Formula One race were immense and completely at odds with the Indy 500. The track required was a totally different configuration. Instead of an oval with 4 corners, the Formula One track would be curved and windy with 13 bends and chicanes. And to make Kevin Forbes' job even more challenging, the 2 racers would travel in opposite directions. The Indy 500 is anti-clockwise, while Formula One is clockwise. In the Speedway's long history, no race had ever traveled clockwise. In fact, many people believed this would bring bad luck. If Formula One was to return to the US, the Speedway would have to overcome superstition and transform itself into a brand new city. And that wasn't all. The inaugural US Grand Prix would be held in September 2000, less than 20 months away. The construction of the Pagoda Tower suddenly paled into insignificance next to this vast new challenge. For Chief Engineer Kevin Forbes, the race against time was now even more desperate. Among the huge list of new construction projects, Forbes would have to build a vast state-of-the-art media center, able to accommodate the army of journalists who travel with the series. An 800-meter-long row of 36 high-tech garages would have to be built in the pits and hospitality suites above them. They would also need several additional buildings for the thousands of Formula One staff. But it wasn't just buildings that had to be constructed. Formula One was a totally different road race to the Indy 500. So an additional 2.5 kilometers of highly sophisticated racetrack would have to be built through the center of the oval. Kevin Forbes now had 23,000 square meters of specially designed buildings and around 370,000 square meters of site infrastructure to design and build in less than 2 years. The construction team had the most challenging undertaking of their careers ahead of them. Just one slip along the way could put the whole project in jeopardy, and any delays could result in the cancellation of the inaugural US Grand Prix. For the Formula One garages and new media center to be finished on time, the construction team needed to have the foundations completed by the spring of 1999. But a major obstacle was coming their way: the weather. The Midwest endures extremes of temperature, and in the winter it can drop to almost -30, cold enough to freeze and crack cement before it can even set. This was enough to potentially bring construction to a standstill and seriously disrupt the already tight schedule. But at this point, Forbes simply couldn't afford any delays. They had to work on, regardless of the weather. The research team experimented with sophisticated solution additives in the cement to make it set faster. They eventually settled on a fine cement mix called Type 3. This keeps concrete from freezing and accelerates strengthening. They also employed blankets, straw and heaters to stop the ground from freezing. These ingenious methods enabled the team to work through the freezing winter temperatures. But despite this, as the weather got warmer, the construction team was still in danger of slipping behind schedule. They were undertaking a mammoth task, constructing more than 23,000 square meters of new buildings, all with unique demands, as well as 370,000 square meters of site infrastructure. The Pagoda Control Tower was now well under construction, as were foundations for the garages, the vast media center and the other Formula One support buildings. But as May and the Indy 500 approached, the construction team found themselves facing a much more frustrating problem. The Speedway wanted its customers to enjoy the '99 race season as much as any other, so the construction team had to cover all the foundations to make the stadium look as if no building was going on at all. The already stressed team was pushed to the limit.
I think every time that we reached an event, the construction team would cringe when we realized that we're now going to have to stop building and start picking that rug up and sweeping everything under it. It just makes the stress and the tension that much worse.
Forbes and his team were true to their word. All evidence of construction was swept away just in time for the Indy 500. In keeping with nearly a century of tradition, the greatest spectacle in racing took place on the last Sunday in May. It went like clockwork, and no one noticed the construction. Kenny Brack won in just over 3 hours to the delight of the capacity crowd. Even those sitting on the temporary grandstand were oblivious to the Formula One foundations being built beneath them. In June and July, construction continued apace. But just a few weeks later, Forbes and his team had to stop again, this time for the Brickyard 400. Once more, Forbes kept his promise of hiding all construction. And again, the race went off without a hitch. Attendance was at near capacity, but no one complained about construction. But catering to these events put further time constraints on Forbes and his team.
I can remember the day after the Brickyard 400 walking into the meeting that kind of kicks off the final phase. The comments from that side of the team was, "Thank God you're done with your bloody races. We can actually get something done now."
With the 1999 race season finally over, Forbes and his men now had to work hard to complete the massive project. In just 9 months, the vast new Pagoda Tower would have to be ready for the next Indy 500. And just a few months after that, they would have to have completed the 370,000 square meters of redevelopment in time for the inaugural US Grand Prix. Time was going to be tight. Then came further bad news. The team had planned to wait until the spring of 2000 to lay the new 2.5-kilometer section of Formula One track. But Kevin Forbes was suddenly told that it had to be built straight away. His schedule had been turned upside down. The whole project seemed to be in trouble. It looked like disaster for the Grand Prix. Autumn 1999. With time running out to complete the massive 370,000 square meters of redevelopment, Kevin Forbes was handed another bombshell. He had planned to lay the new 2.5 kilometers of Formula One track in the spring of 2000. But then he received new information that turned his plans upside down. Constructing a modern racetrack is very different from laying a normal motorway. Major roadways have to be able to take the weight of huge trucks and lorries, but these vehicles exert vertical downward forces. The problem for a racing track is the incredible lateral forces created around corners. A typical family car traveling at normal motorway speed exerts around 360 kilograms of lateral force on a corner. But a Formula One racing car traveling through a corner at 320 kilometers per hour creates almost 6,000 kilograms of lateral force. This means that the asphalt can actually slide underneath the car with devastating effect. Added to this, these super-light cars create a massive downward force of around 2,200 kilograms, so much that they could hypothetically race upside down. A modern racetrack needs to be strong enough to hold against such enormous loads, because the consequences of poor construction can be catastrophic. But for the asphalt to obtain maximum strength, it needs to oxidize, and that takes time. The problem for Forbes was that he had no idea how much time. He called in the experts, and to his horror, he discovered that for the asphalt track to gain optimum strength, he would have to start laying it immediately.
And it basically told us that we couldn't pave it soon enough, that we had to instantly start earthwork operations so that we could get the asphalt down as soon as possible.
14,000 tons of asphalt track had to be laid without delay. This put Forbes' plans in crisis. And this colossal new undertaking was just one of the challenges he had to meet. He also had to consider all the other construction needs on the site. A mammoth task had just got bigger. Before Forbes and his team could start laying the asphalt, they had to be sure that the mix was suitable for Formula One. In the testing area at the Speedway, a research team checked the qualities of different asphalts. The primary concern with any kind of asphalt paving mix on a racetrack is how stable it is on the corners, where the lateral forces are concentrated. If the mix is wrong, the track can slide underneath the car. Particles displaced from the surface can also cause a lack of traction. Either can spell disaster. For this Formula One track, the mix needed to be stiff enough to avoid lateral movement of the asphalt, but at the same time allow the asphalt to expand and contract in the extreme weather conditions found in Indianapolis. The team experimented with air-cooled blast furnace slag, a byproduct of making steel. This is a very angular aggregate and doesn't polish easily, meaning cars get a much better grip. It also allows for absorption of the asphalt cement, which lets the final layer expand and contract. But this mixture needs a long time to oxidize and gain maximum strength. And unless Kevin Forbes could start laying it immediately, the asphalt would not be hard enough and could lead to devastating accidents. Then, to add to Forbes' continuing nightmare, the weather once again began to work against him.
It did become very challenging at the very end. Keep in mind that you can't pave in the wintertime. that the compaction of asphalt is a function of temperature. That if it gets too cold, you cannot compact the asphalt, and that's a very critical aspect of bituminous construction. So we knew that if we weren't paving in August or September of 1999, we were not going to make the schedule.
They brought in an asphalt paver that could lay down between 7 and 8 meters per minute of the specially designed track. 14,000 tons of asphalt had to be laid in just 4 days. It was now a race against time and weather. Construction had to continue around the clock if they were to finish on time. At last, after 4 days, this particular marathon was finally over.
We have just completed a 1.5 miles worth of infield road course that, you know, in itself is just not a 1.5 mile strip of asphalt. It's got sensors, it's got timelines, it's got observer stations, it's got safety station networks all around this. So it's not just a typical piece of asphalt.
In its 100-year history, the Indy Speedway has witnessed many accidents. In the early days, many were fatal. Most of these driver fatalities were caused by cars losing control on corners and hitting the concrete barriers at speeds of more than 300 kilometers per hour, a massive and potentially fatal force. On impact, this G-force is 30 times greater than on a space shuttle launch. Few people survive such a collision. The Indy Speedway was already arguably the world's most famous racetrack. But owner Tony George wanted his updated speedway to be at the cutting edge of safety. So as the speedway underwent its biggest reconstruction in history, the owner demanded that research on crash barriers be pushed to new heights. The research focused on reducing the G-force on impact by using an energy-absorbing barrier. In 1998, the Speedway began to employ new barriers called PEDS, which stands for Polyethylene Energy Dissipation System. High-density polyethylene is very durable. In theory, it can cushion huge impacts without being destroyed. To test out the new PEDS barriers, the Speedway attached them to the inside of Turn 4 at the Brickyard 400 in 1998. They chose this corner based on the assumption that it didn't typically experience major impacts. They were wrong.
Oh, up against the wall. Lyondike goes down, takes the inside wall, and tears that car up.
During the first support race, the PEDS barrier sustained one of the most severe crashes ever recorded in stock car racing history. Racing driver Arie Luyendyk struck the barrier at over 200 kilometers per hour. His car was completely destroyed, and debris was showered across the entire width of the track. The research team at IMS reconstructed the crash from videotape. On impact, the trial PEDS barriers essentially absorbed a great deal of energy, but such was the enormous force of the crash that it actually shattered the barrier, spreading it across the track. The researchers concluded that the barriers had saved the driver from a much greater and potentially lethal force. Luyendyk was able to limp away from what easily could have been a fatal accident. The incident demonstrated that the energy-absorbing concept could be made to work. The research team then began experiments using different materials. Each new material was tested over and over. Each time there were new problems. Could the team fulfill the Speedway owner's ambition and make the Brickyard the safest track on Earth? 27th of May 2000, with just 24 hours to go to the Indy 500, Chief Engineer Kevin Forbes and his construction team were working around the clock. They were battling to finish the biggest reconstruction program in the US Speedway's history. 370,000 square meters of site infrastructure needed to be complete for the inaugural Indy Grand Prix in September. But for today, they just had to have the huge new pagoda control tower ready.
We had always said that failure was not an option. And we said that come opening day, May of 2000, the pagoda was going to be ready. And our gates opened at 8 o'clock that morning, and at 7:56, the last of us took our brooms, our shovels, our boxes, whatever we had to take with us to say it was done, and we all kind of looked up at it and said, it's done.
New pagoda at last complete, the gates opened at 8 a.m. Around 400,000 fans streamed into the massive complex. On this one day, the Indianapolis Motor Speedway was host to arguably the greatest event on the planet. But everything would need to run smoothly if the Speedway was to live up to its name as the biggest and best sporting stadium on Earth. This city within a city had to provide every conceivable amenity. Motor racing can be a dangerous sport, so there were over 100 doctors on call, as well as an ambulance service and fire department. And with more than 26,000 litres of high-octane methanol fuel around, they had to be ready for anything. In the lead up to the big race, sales of food and drink were truly epic. During the course of this one day, nearly 200,000 hot dogs were consumed. If laid end to end, this was enough to circle the track more than 7 times. Nearly 17 tons of hamburgers and 23.5 tons of fries were devoured, the equivalent in weight of 7 African bull elephants. Over 150,000 litres of soft drink were served. Nearly 500,000 bottles of water and close to 300,000 litres of beer were swigged. As the fans settled in for the race, no one noticed that nearly 2 years of sweat and toil on the pagoda had only just finished. At last, everything was ready.
Gentlemen, start your engines.
This was the moment the entire construction crew had been waiting for. They breathed a collective sigh of relief as the 33 Indy racing cars hurtled down the 800-kilometer course. Juan Pablo Montoya won the race in under 3 hours. But the extraordinary new pagoda control tower was the real star of the show. The unique 10-story control tower stood proud at more than 60 meters tall. It covered almost 7,500 square meters and was resplendent as the new brain and beauty of the track. But for Kevin Forbes and his team, the work was far from over. They now had just over 2 months to complete the Formula One construction needs. Buildings were still under final construction. and the entire configuration of the track had to be changed in just 6 weeks. This was the final race against the clock. Would Forbes and his team make it in time for the Grand Prix in September? Kevin Forbes and a team of about 100 men began the massive task of turning around the track for Formula One.
I think for the team here, for the guys here who work at the Speedway that helped that transformation take place, it's probably by far their biggest challenge.
Barriers weighing a total of more than 1 million kilograms had to be moved. 2 huge temporary infield grandstands and new safety fences needed to be erected. Tire barriers were installed using over 50,000 tires. New track signs and markings had to be put in place, as well as the new Formula One starting grid. It was a mammoth undertaking. In just a few weeks, dozens of demanding experts from Formula One would be arriving. They would expect everything to be ready: the garages, the media center, hospitality suites, and, of course, the track. And to make things even more difficult for Forbes and his team, the Speedway owner wanted to make the infield track more or less disappear when it wasn't in use by Formula One. The PGA golf course had 4 holes on the infield, and outside of race days, the Speedway owner wanted golfers to feel like they were in beautiful parkland, not a racetrack. It was yet another headache for Kevin Forbes, as it meant he had to make all infield barriers and grandstands temporary. On the 20th of September 2000, Formula One finally came back to the United States after an absence of 9 years. And where better than the home of motor racing in America, the Indianapolis Motor Speedway. But would everything work for the demanding new visitors?
It was probably one of the most intense moments of all of us, that every employee here at the Speedway, every project manager, every tradesperson was involved in trying to put the last-minute pieces together. I think the amount of stress the entire team kind of went through and endured throughout the entire progress was probably carried right on through the event and right after the event. I don't think any of us were ready to openly admit how tired and how stressed we were.
The US Grand Prix was finally underway for the first time in nearly a decade. The race was a roaring success, with over 200,000 fans watching Michael Schumacher win the 73-lap course. There were no major incidents, and Formula One was ecstatic. And there was more good news. The crash barrier research team had made a major breakthrough. For over 2 years, they'd been experimenting with different energy-absorbing materials, and at last, they'd found the perfect answer: steel. Thin steel sheeting has the same flexibility as polyethylene, but unlike the hard plastic, it resists destruction. The revolutionary new system was finally installed in time for the Indy 500 in 2002. The barriers were called SAFER, for steel and foam energy reduction. But the Speedway didn't expect them to be tested quite as quickly as they were. On just the second trial day, driver Robbie McGee spun out of control. He smashed the SAFER barrier at approximately 250 kilometers per hour. Such an impact into the old barriers could easily have been fatal. But McGee suffered only minor injuries and limped away from the crash. SAFER barriers have now been installed on virtually all high-speed oval tracks in the United States. To date, there have been no serious injuries sustained during a SAFER barrier crash. This barrier remains a powerful demonstration of the Speedway's commitment to the future of motor racing. Finally, the Speedway could reflect on its crowning achievement. Kevin Forbes and his team had done the impossible. 370,000 square meters of redevelopment and infrastructure in less than 2 years. It was the most dramatic and comprehensive overhaul in the history of the track. Despite less than ideal conditions, the crew suffered only one minor accident and no lost time, an amazing feat in itself.
And quite frankly, it doesn't embarrass me to tell you that, because on the flip side, we had the most perfect plan in place to make sure that they were either minimized or they didn't become an issue.
For the beginning of the new millennium, the Speedway was the most versatile racetrack on the planet, and the safest. Tony George's vision and high-stakes investment had paid off. The Brickyard is currently the only track on Earth to have 3 of the world's premier racing leagues and host them for the biggest sports crowds on the planet. The Indianapolis Motor Speedway is one of the world's true mega-structures.
Don't miss a brand new episode of Air Crash Investigation, Hidden Danger, tonight at 9. Next, what are your chances of surviving a train crash? Find out after the break.